we're going to use Desmos a little bit today. Just to make sure that we all can do this, if you will go to Desmos, we'll use that same AP test in Desmos that we used last year for pre-cal. Hopefully you got it bookmarked somewhere. If not, just Google like College Board version graphing calculator, and I would bookmark it, because there are not many differences between just regular Desmos and the College Board version, but there are a few, so you don't want to be relying on something that's not going to be available to you. One of the ones that I am pretty sure, like in regular Desmos, if I do 2x plus 5 equals 7, actually the College Board does it. I don't think North Carolina does that. Let me see about that. 2x plus 5 equals 7. Oh, yeah. North Carolina version, if you do 2x plus 5 equals 7, it will not show you anything. But if you're in College Board, actually it did. I mean, you guys should be able to do that so easily that this is not an advantage, but it does graph you a line at 1, so 1's the answer to that. I didn't realize it did that. Okay, I don't really know what the major differences between College Board and regular Desmos are then. I should go look that up to see, but for the most part they're the same, but I would use this one. So if you want to do a table in Desmos, you know what? I think I know a better way than this now. I learned a better way. This will work, but I think I know a better way now, and I should have changed my notes. Let me see. I do know a better way. Ignore my first page of notes. I just realized that I know a better way than this. Actually, it may not work. Let's see. No, it works. And then you can type in. Oh, yeah. Okay. All right. Let me just update this while we're. Okay. Actually, what we want to do is we want to, number 1, you can just write. Let me get rid of this. Okay. Enter your function. And we'll say we're going to use f of x equals 3x plus 5. And so if you just want to write this over to the side. What is there works. It's just not the easiest way. I don't know if they added it or if I just learned this later, but then you are going to click on the little gear right there. And then you are going to click on the little table right here. Oh, there it is for this one. And then we will type in desired x values. So you want to click that. It's going to come up with a table. It will automatically do -2, -1, 0, 1, 2. That's its default. But for what we're going to do, we're going to need different numbers. So if I want to plug in 8, I just plug in 8. And I can go down 9, 10, 11, 12. You know, whatever numbers you need. You could plug in 1.7. You could plug in square root of 3. You know, whatever numbers you need to plug in there. So I apologize for my faulty notes. This is better. Do it this way. Okay. So one thing I need to make clear is that tables are not proof. Tables can support an answer. Okay. So this is kind of like whenever you like know people that have done things, it may not actually be proof. Maybe you have seen that kids who play football get too many concussions, right? And we maybe think that because Solomon is out with a concussion right now. Is Solomon getting a concussion proof of that statement? No, it is in support of that statement, but it doesn't, like, we're not looking at the bigger picture. We're not, or we could say, like, maybe you got 2 or 3 of your friends that play football that all got concussions, like, within the same week. It feels like, kids are really getting more concussions these days. And it feels like because you know those 3 people that that's the truth. But you would need all of the football players in the country to be able to, like, prove that. In fact, you really, like, when you're dealing with things like that, you can't ever, like, prove it on a theoretical sense. You can support the answer. So everything we're doing today is going to be from tables. So unless you have a statement that directly goes against the table, you can't prove it, but you can support. There's evidence to support that this is the case, right? So now that we've got that working, let's go to this. Okay, so limits with tables. So let's say that you've got 2 natural log of x minus 2, and we're looking for the limit as x approaches 2 from the right. And we do not know how to do this algebraically. In fact, we're really not going to learn how to do it algebraically on this type of problem. And we don't have necessarily a graph, although if we're using Desmos, it will graph it for us. But I want to focus mainly on the table. So I'm going to type it in. I like using function notation. I think it'll work with y equals. Actually, will it? Let me see if that's true. Yeah, it'll do it. It'll do a table with y equals or f of x equals. It really doesn't matter. Now, I could probably figure this out from the graph that it gives me. Here, sometimes it's a little hard to see from the graph, depending on what type of problem you're looking at. Plus, if you guys remember from pre-cal, if there is a hole in the graph, is this going to show it? It will not. You can find it by, like, dragging along and seeing if there is a hole at that point, but it doesn't, like, show whenever you graph the point. So the table can be used for further verification. So I'm going to do the limit as x approaches 2 from the right. Those are the numbers bigger than 2, right? So I could start maybe with like 10, and then maybe 5, and then maybe 3. Give me a number that's also like that's closer to 2 than 3. 2 point what? 25. Okay, that'll work. Give me something even closer to 2. You can see 2 is undefined. You could try just plugging in 2 first. That might work, but 2.1. Okay, something even closer. 2.05. Even closer. I would do this 2.01, 2.001, 2.0001, right? Just put more zeros in front of that right there. These numbers are getting closer and closer and closer to 2, but they're still decreasing a little bit, right? 2. I don't know how many ones it can take. Sometimes you get where, like, sometimes Desmos just can't take it anymore. Let's see if we can make it reach its limit. No, not yet. That's pretty good. Yeah, so like at this point, it's telling me that it's undefined. I think Desmos does like 10 decimal places is probably, like, if you get past that 10 decimal places, whatever it's giving you may not be accurate anymore because it's just kind of ran out of computing capabilities for it. So this is actually not undefined. It's just so close to 2 that Desmos is calculating it like it's 2. So we can kind of ignore this last one, but what do you see happening to these values? They're getting smaller. Do they seem to be like evening out at a number or just like going down? Going down, right? And so I would say that this table is supporting, oh, that was not supposed to go to the next one yet. I would say that this table is supporting that this limit equals negative infinity. There. And the benefit of Desmos is you can also see the graph. So if we look at the graph, if I were to type in x equals 2, right there, it'll put me a line, and I can see, oh yeah, what would we call that vertical line that I just put there? Vertical asymptote. It looks like we're getting closer and closer and closer to, but not touching it, and our values are just going to decrease forever right there. Okay. Let's do our next one. Okay, for this one, I'm going to say f of x equals x plus 3 over x to the second minus 5x minus 24. And this time we're looking for x approaches infinity for this one. I can look at the graph. What do you guys think is going to happen there? Nope, I don't think 9. Now, something is happening. I think something is happening at 8. For sure. But we're looking where our x values are going towards infinity, right? So at 8, there's definitely something going on, something interesting that they might want to ask us about. But is x approaching 8? It is not. So we're looking where our x values go to infinity. So we're looking like, 20, 30, 40, 50, 60, 1,000, a gazillion, whatever we've got out here. So we're looking like way over here, what's happening to that graph. Now, again, the table can be helpful on this because sometimes it's a little hard to see. So if you're thinking about your x's approaching infinity, maybe you start with 10 and 100 and 1,000, and you just start putting lots of zeros. What does it switch to right here? What is that? Scientific notation. What does it mean when we have a negative exponent?
Very small.
Very, very small, right? That decimal's getting moved like right here 5 places to the left, so it's going to be 0.00001 0008, like very, very small, right? And then this one's going to be even smaller because the exponent is negative 8. And then you might be able to break it. Oh, you got to go way out there to break it. It's it just depends. Like sometimes you can go far enough that like Desmos is gonna be like, whoa, I'm not doing this anymore. But these are really, really, really small numbers. What are they approaching? 0. You're approaching 0 for this. And on the graph, the way that looks is, if I put this over here, it is because we were looking way, way, way over here. And always when you're doing limits, you're talking about what the y value is doing, right? So as you go over here, these y values just get closer and closer and closer to 0. You can see, though, if you zoom in, you're not actually touching 0 yet, right there. Okay, does that make sense? Okay, so on some of them, you'll be able to use Desmos. On a lot of the stuff, like our AP Classroom assignment, you won't, like they're just going to give you a table. They won't give you the equation. So it will look more like this. Okay, so it says, which statement is supported by the table below? And they've given you the table. And then we've got limits. And we're going to try to figure out which one is supported here. So, I noticed that I've got x approaches 2 from the right, x approaches 2 from the left. Most of these deal with 2. This one right here says x approaches -4. Now, when I look at my x values, I'm looking at the table, and I only see values from 1.5 to 2.5. Am I going to be able to tell anything about what's happening when x is -4 right here? No. So, what they're trying to do is trick you because the answer is 2 over here. So they're trying to make you think that 2 is an x value, but that's a y value right there. X approaches -4. We're not going to be able to tell anything about it. We can't tell whether it's true or not true because our table doesn't focus on -4. Right? But our table does sort of center around 2 as an x value. Because if we did have 2, it would fall right here between 1.999 and 2.001. Okay, so let's run through them. It says limit as x approaches 2 of f of x equals -4. As my y coordinates seem to approach -4 here from both sides. Over here, this number is really close to -4. But what about over here? Is that number close to -4? It's positive. So I would say it looks like this limit probably does not exist, right? It looks like they're going to different numbers. We can't say it for sure, but we could support it, right? So I would throw out A. Okay, then I've got the limit as x approaches 2 from the right. So from the right, I'm coming from over here, right? Numbers higher than 2. 2.5, 2.1, 2.01, 2.001. On the right side, does it look like I'm getting closer and closer and closer to -4? Now, what does it look like I'm probably getting closer to? +4. So this one cannot be correct. But the last one, limit as x approaches 2 from the left, so 1.5, 1.9, 1.99, 1.99, what does it look like my y values are probably doing here? Could be supported that it approaches -4, right? Because you are at -3.97. Not a guarantee, but it does support. That's the answer. Okay. Just to, any questions on that? Just to prove a point, I have given you this question here, which says which statement must be false according to the table below. In order to answer this, it has to directly go against the table. Okay, so if I do limit as x approaches 0 of f of x, so 0 would fall right here. Right? Limit as x approaches 0 of f of x equals -5.5. Should we say that must be false? I would say it looks like it's probably true, right? Like, I don't know for sure, but it looks like that. But from both sides, I'm approaching -5.5. So that would not work. The limit from the left and the right of -0 equal each other. Well, that also looks like it's probably true, right? It looks like this is true, which would make B true. So it looks like it's probably true. What about the limit as x approaches 5.5? Or our x's, do we have 5.5 on here at all? So certainly our table does not support that statement, but does it tell us it's false? No, it does not. Okay. And then what about the limit as x approaches 0 of f of x does not exist? This does not look like it's true, right? It looks like we're going to have a limit. It looks like the limit is going to be -5.5. It looks like A is true. It looks like this is probably false, but do we have all the numbers? We do not. There's a chance there's a vertical asymptote right there, and really the limit does not exist. Like, this is going to keep on going. It doesn't look like it because like the differences here start getting smaller and smaller. I wouldn't say that it's supported, but we don't have all the facts, right? So I have given you this one just for the simple fact to warn you is that you cannot, you cannot make certain conclusions from a table. Unless it goes directly against the table. And in that case, it would have to be something like this. F of 0.1 equals 6. I could say that's false, right? Because F of 0.1 is not 6. It's negative 5.2. They give me that specific point. But that's really about the only thing you could say that is false. You cannot make certain conclusions about limits from a table. So I mostly am giving that to you here just to know that we don't know everything that's happening at the table. It can just support for that. Okay. All right. So that's generally the idea. Words. So you are going to say the limit as x approaches two of f of x equals 5. There's other ways you could word it, but I would just write it this way. Whenever you make the graph, there's some specific things I'm going to be looking for, okay? I want you to label your x and your y-axis using your function notation. So if I have f of x, whatever's on the inside of the parentheses is your independent variable. It goes on the horizontal axis. Now, this is one of the most common ones that we see. It is f of x. So x goes on that x-axis. And then we could sometimes call this the y-axis, but since we're using function notation, I'm going to label this as f of x. Okay, so on all these problems, I want you to label the axes. I also want you to label your table that way. So like this is going to be x, this is going to be f of x. So both your table and your graph need to be labeled in that manner. Now we've only got one criteria here, and that is as x approaches 2, our y coordinate has to approach 5, right? So this graph at 2, 5, I have to have an open circle or a closed circle. It does not matter. The graphs that you make for this could vary widely. Just to make things interesting, I think I'll put an open circle there. 2, 2, 5. I'm gonna put an open circle. Doesn't have to be. It'll be a closed circle. And then it does not matter what else your graph does except for it's got to connect. And be careful. These are all functions because we're using function notation. So make sure it can still pass a vertical line test. Don't do any crazy like backtracking or anything that would make it not a function. Now I can just leave it like this. This is fine. Right here, you could put an extra dot somewhere if you want to, whatever you want to do. There, you could have drawn me a straight horizontal line that goes through 5 right there. That would work, right? Lots of options on what you want to do, what you can do here. Then I need your table to match your graph. So I need your table to match your graph and support the limit statement. Like if I didn't have the graph here, I could still sort of see this from the limit or from the table. So what number are we really focused on in this table? 5 is the y coordinate we're focused on. What about the x? 2. So I need to show that I'm approaching 2. What I would do, so we got 1, 2, got 9. I would make this middle, I'd make that middle number 2. Right there. Now for us, what's the value of the function at 2 on the graph I've drawn? Nope, not on the table. It does not have one, so we would put undefined. Now, if I used a closed circle there, it would be 5, and we would put 5 on the table. And then we want to support that x is approaching 2, right? So I would maybe, you can choose to do what you would like here, but I would maybe pick maybe 1 and then 1.9 and 1.99 and 1.999 over here on this side. Okay, now I need it to match the tape. I need it to match the tape, the graph, right? So I know the numbers are going to get closer and closer and closer to 5. Are they going to come from the bottom or the top? Is it going to be like 4.9, 4.99, 4.99, or is it going to be 5.1, 5.01, 5.01? On my graph, from the left, right? These will be left. Am I below 5 or am I above 5? Below, right? So I need it to match. So like something reasonable at 1, like you can actually look at your graph and see what you think your values are. I'm going to say maybe that's 4.7. Doesn't have to be exact, but it needs to match the patterns I'm seeing on the graph. And then maybe at 1.9, maybe we are at 4.9 there. And then I would go 4.99 and 4.999. So this table supports that from the left as x approaches 2, the y coordinate is getting closer and closer and closer to 5, right? Then I want to make sure I show that on the other side. So I would do 3 right way over here. And then maybe like 2.1 and 2.01 and 2.001. And I do get these mixed up sometimes. Sometimes you might need to make yourself a little number line, because sometimes I find myself here doing like 2.9, 2.99, 2.99. That's not right. That's getting closer to 3, right? That'd be incorrect. Okay. And should these values be like, should they be the same? 4.7, 4.9, 4.99, 4.999? Or we need to have numbers bigger than 5 over here. So if I look at my graph, it looks like at 3, my y coordinate is about 6. But then by the time you get to 2.1, you're getting really close again. So you might want to do like 5.1, 5.01, 5.001. Now, there's a lot of different things you could do here. This is pretty open-ended. Yours may not look exactly like mine if we weren't doing it together. So there's a lot of options that can happen here. Okay, I think this is a very good thinking exercise because you got to think about the multiple representations that we want to know about. And you've got to picture what this limit looks like without being, I think it's easier to answer what the limit is than to draw a picture for that limit. Let's go down and I want to do number, I'll do number, hold on, let me look and see what I assigned. I think I said we were going to do 9 together. over here. Oh, 10. Yeah, we're gonna do number 9. Okay, so I got limit as x approaches 4 from the right of f of t is 0. Limit as x approaches 4 from the left of f of t is 2. Okay. I'm gonna do the written description first, just because I think it's the easiest of the 3 things we've got to do. And you just basically write this out in words. The limit as t approaches 4 from the right of f of t is 0, and the limit as t approaches 4 from the left of f of t is 2. I would label my table and my graph. You're going to have t and f of t. Here the x-axis is t. The y-axis is f of t here. Those are easy to forget. I am primarily concerned with what happens at 4. Right, so 4 right here is a big concern. From the right, my graph approaches 0. From the left, my graph approaches 2. So, I'm going to have some type of point at 4, 0. Right? So 4, 0 here. Yeah, give me a pass there. I'm going to put a closed circle on that one. And then I have to have another type of point here at 4, 2, right? Can it also be a closed circle? It cannot, because it won't be a function anymore. So I can use an open circle right there. Now, I could use open circles for both. It doesn't matter. Thank you. All right, now, this is the limit as x approaches 4 from the right. So I need to connect this over here somehow on the right side. And this is the limit as x approaches 4 from the left. So I could do whatever you want over here on the left. I'm going to go horizontal line. Doesn't have to be, I just picked that. Okay, when you are doing your table, what's the x value that you're really concerned with? 4. So I'm going to kind of put it right here in the middle. Right, and I need to approach 4 from the left and from the right. So I might want to do like 3, 3.9, 3.99, 3.999, and from, let's see, that's from the left, and then from the right, maybe I want to put a 5 up here, 5.1, no, I'm doing that wrong. What I'm doing, 5, 5.1, 5.01, 5.001, what number am I approaching? 5, not 4. Let's try that again. 5, 4.1, 4.01, 4.001. Right, those numbers are getting closer and closer and closer to 4. I do want your table to be like in numerical order, so it needs to go lowest to highest. So don't do it backwards. Okay, what is the value of this function at 4? It is 0. Okay. What is the value of the function at 3 or 3.9 or 3.99 or 3.999? What's the y coordinate? 2. It's 2 all the way across because I drew a horizontal line. Now you could draw something else. It doesn't have to be that way. But for me, it's a horizontal line. So it's 2 all the way up as close as you can get to 4, then it jumps back down. Then over here, it doesn't matter so much what you do except for what needs to be happening with your numbers. They need to be decreasing. Also, I need to be close to 0 right here. So this might be like negative point. Actually, probably the best thing to do right here is do this. Go see what your 5 looks like it is. This looks like it's maybe negative 0.7. All right, so negative 0.7. And then just get closer and closer to 0. So like maybe this is negative 0.3, and maybe that's negative 0.1, and maybe that's negative 0.01, something like that. Okay, so we got like 10-ish minutes left of class. What you're going to do is I have assigned one of these to everybody. Everybody's going to have a partner. And you are going to complete it. And then one of you is going to post it to the discussion board on Canvas for me. Take a picture with your phone, post it to that discussion board on Canvas, or you can take a picture with your computer, either one. And then what you'll do tonight, although Matthew and Saul, if you have time, also do 8, but if you don't have time to get to it, that's okay. I just didn't have enough people here. So,